It is snow. This is movie snow. Do you ever wonder how they film all these winter movies in California? We need snow. And so a super absorbent polymer, it feels like snow. You can ski on it. It sticks to you like snow. The only thing you can't do is pack it together and actually make a snowman out of it. But you can take this material, if we throw it in the oven and dry it out, I can redo the process the next time I want it to snow in Potsdam, New York. Well, it snows here enough, so I don't have to worry about it. I'm actually going to leave this up front, so after the magic show, if you want to come down and check out the movie snow, you certainly can. You know, a super absorbent polymer making snow. All right, we got to get going here. You guys have places to go. Let's see what else we got. I'm gonna do this one. Chemistry, combustions. Those are the interesting things. We like to talk about combustion. Here I have something. This is a mixture of a nitrated polymer called nitrocellulose. It happens to have. That might be a little too much. Unless you want to do it all. It happens to have a little bit of magnesium, a little bit of aluminum, a little bit of a few other metals in there. Chemistry is the heart of pyrotechnics. If you happen to go out on the 4th of July and see the fireworks in the sky, this is basically chemistry. And so, in my flask here, I have a highly combustible mixture of materials that resembles a pyrotechnic mixture. You on top? Let's see, if we ignite this mixture, we essentially have the 4th of July. And so, a very simple mixture. A nitrated cellulose polymer with a little magnesium, a little aluminum, some gunpowder thrown in there for good measure. And we get a pyrotechnic, we get a 4th of July reaction. We're down to this one. Any other ones hiding back there? All right, so we're getting close. I need another volunteer. No, I need a younger volunteer. I know you big guys, you don't need to do that. Volunteer, volunteer. Who? You want to volunteer? I see his hand waving up there. Come on down, let's see. All right. This one I'm actually going to make you work, and I'm not going to blow you up. All right, so we're going to do an oxidation reduction reaction. This is one of the hardest reactions that I do, the hardest reaction of the day. So, what's your name? Matt. All right, Matt's going to help me out here. First thing you need a reaction bottle. You need some chemicals. These are all empty. There's one that's not empty. Okay, we need a reaction bottle here. We're going to take that one. You need one of those, you need one of those, I need one of these, I need one of these, I need one of these. And now we're going to do some chemistry. Take the top off your bottle. Okay, we got everything. Oh, before we do anything, what's he need? Safety glasses. Okay, I happen to have here a pair of safety glasses. Perfect for him. Okay, so if you put those on, please. See, will they stay over your glasses? Okay, they're good. You see? Yeah, all right. So now, what we're going to do is you're going to take your silver solution. This chemical here is silver nitrate. It's photosensitive. If you get it out, just like film, and they will turn black, and they will stay. So you don't want to get the chemicals on your hand. All right, so you're going to carefully pour these in. Carefully pour that into your bottle. Okay, now, we need to... Now, we need to add a little bit of ammonia. What we don't have here are any pipettes. Do you have any pipettes hiding back there? Where's that bottle that I just did? Right there. Give me that pipette. Okay, we'll improvise. Clean that out. Now, what we're going to do is we're going to add a little bit of ammonia into our reaction vessel. Then we're going to stir it up. Since we only have one pipette, I'm going to do this. Stir that baby around. Swirl it around. We've made this brown crud. We don't want that brown crud. So we're going to add a little bit of ammonia. Swirl that baby. And you can see the brown crud that was there has disappeared. It's magic. Hooray. Thank you very much for coming. All right. Just kidding. Just kidding. All right. So now, what we're going to do is we're going to increase the pH by adding some potassium hydroxide. This guy right here. Dump that right in. When we dump that in, we should get, maybe, that brown crud back. Okay, if we don't get the brown crud, that's okay. Oh, wait, we get a little bit of the brown crud. We're going to add some of the ammonia. We need to get this going. They falling off? Okay. In my chemistry class, we talked for 45 minutes about why the same material makes it come and go. But for now, we're going to say that we are complexing the silver. All right. So we got our ammonia. Now, our last ingredient. Our last ingredient is called dextrose. It's a sugar. What we're going to do, hold on, don't dump that in yet. What you're going to do is you're going to take your dextrose, you're going to dump it into your bottle, you're going to put your cap on your bottle, you're going to put it on very tight, you're going to start shaking like crazy, and hope it doesn't blow up. Okay? You ready to go? Yeah. All right, get your cap on. Dump it in. Boom! Just kidding. Now, get your cap on good and tight. Now we got to shake. Shake, 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 shake. Sideways. You got to shake it sideways like that. Back and forth, back and forth. Turn it this way. You got to do it the other way. You got to turn it right upside down. We got to get the liquid in the neck. That's the hard part. You got to turn it sideways. You don't want to go in the same direction for more than 2 or 3 seconds. You got to shake it back and forth. You got to put it over your head like this. That's the best part. All right, you got to bunny hop. You got to do the bunny hop. Come on. All right, here we go. All right. Keep on shaking. That's the best part. All right. We're going to have to shake these for about 45 minutes. Alright, so you keep shaking in all directions, right upside down, turn it until it goes right up in the neck. I'm going to talk to them while you shake, okay? Right now we are doing an oxidation reduction reaction inside a bottle. We are taking that silver, which was in solution, and we are reducing it to silver metal on the inside of the glass. We are actually making a mirror. This is how mirrors are made, by the reduction of silver ions in solution. Now, silver is expensive. There are lots of shiny metals. Why do we choose to make our mirrors out of silver? It turns out silver is not even a good mirror. Silver, keep shaking, don't quit, it'll explode. Silver is not even a good mirror. It does not reflect all the light that strikes your surface uniformly, as a matter of fact. So, some of the blue colors are not reflected 100%. The reason that we make mirrors out of silver is that when we look at ourselves in a silver mirror, our skin tones have a nice, healthy, pinkish color to them because of the absence of the blue. We make our mirrors out of silver for vanity's sake. Literally, look better in a mirror made out of silver than any other metal because it does not give you a true reflection. So, the next time that you look at yourself in a silver mirror, just remember, you don't look that good. What I see is not what you see. Your reflection looks better than you actually do. Okay, so we got to keep shaking these things for another second here. We're going to finish these up and then we're going to clean them out. So we need a waste container. We're going to need a little bit of distilled water. We're going to need a funnel if we have one. All right, how we doing? How's it look?
Pretty good.
Looks good. All right. So now we've got our silver mirror inside a bottle. We're going to take our top off. We're going to pour the materials carefully into the waste container. You can see there's some small amount of silver that did not adhere to the surface. We're going to rinse this out. Take that. Shake it around really good. Pour it into the waste container. Okay. Whoa, we're pretty full here. I don't know who gave me such a small waste container. Whoa, ooh, that might be the last one. Okay, we're pretty close. Now, if you take that bottle and you let it dry for a couple of hours. Leave it like that, let it dry. After it's dry, put the cap on, leave the cap on. It will stay silvered for as long as you have it. For as long as you keep it on yourself. You can have this as a memento of your time here at Clarkson University. So,